Hi everyone, welcome back. Today we will be going through a concept called image captioning. We will be building a complete model and I will be going through all the processes one by one completely. Here you will be getting a complete code with results. Initially I will show the result of this work, okay? And then I will go for the explaining part. Here you can see this is end result of our model, that is image captioning model. What is actually image captioning? Image captioning nothing but if you have any image, when you show a image, when you feed a image to a model, it should give you a description about that image. For example, here on screen what you can see is a dog is swimming. So what description we are getting is a black and white dog is swimming in the pool, like that. If you feed this image, the below image, it says a black dog running through the ocean. It's almost right. And here a man in green shirt and blue helmet is running down a street. Yeah, he is skating, but it is running. It's almost a very relative. And then a person in red and white pant is riding a snowboard. It's 100% accurate. And then comes a dog runs through the snow. It's also correct. And then a dog running through the water. Yeah, fine. Now two dogs are playing with the toy. It's almost right. Then a boy in yellow shirt is doing a trick on skateboard. It's not yellow shirt, it's green, but it's what very near to the approach. And then comes a girl is jumping into water into the water. Okay, prediction is almost right. A man is standing on a rocky cliff overlooking large mountain. Hmm, it's somewhat far away from the reality. Yeah, a group of people are sitting on a dirt track. They are sitting on a beach. It's like beach will be a dirt track again. Yeah, a man with a mouth is holding a cup. It is far from the reality. It means our model is working fine. Okay, and I will show the accuracy and losses of this model. Here you can see accuracy is very less. It's 50%. We can increase this accuracy. I will tell you here I only executed till 12 epochs. 12 epochs is very less. You need to run it around 100 epochs. And also you need to do so many other extra pre-processing things. You need to increase the model size. Okay. And there are so many other steps you can do to increase this accuracy around 90 to 95%. Okay, and validation accuracy is 40%, but it's increasing. Okay, we can change this and we can increase this. If you make this epoch to 50, minimum 50 epochs we need to keep if we should get better accuracies. Now we will start from beginning. Initially our first question will be, what is the dataset that I am using? The dataset I am using is from Kaggle. You can see on the screen, this is the dataset. Okay, which has got around 8,000 images. That's why they call it as a Flickr 8K dataset. Is it is having 8,000 image dataset with a text file, as you can see here. Okay, I already said that link for this in the Jupyter notebook, which I will be sharing to you. You can just message us or just can call us to the contact number given below. I'll just share it for free. Okay, don't worry. Otherwise I will try to push it to GitHub so that you can access it very easily. Then we'll start. We got to know that what is image captioning. Now we'll see what are the applications that can be done using this image captioning. First thing is, already Nvidia is trying to create a technology like a image captioning technology for people who are having no sight or low eyesight. Okay, and the second thing is for example cross-lingual image captioning, we say. For example, there is a video, okay, and it is having language say English. but a person who is watching that video is from China. Okay, now what we can do, we can take this video, but capturing can be done in Chinese if we train the model using images with Chinese captioning. We can do it for any language, especially Hindi and Kannada, Tamil, Telugu, Malayalam. On any language you can do that. Cross-lingual image capturing can be done. This is a very useful concept, and there are so many other applications. Here you can see recommendation in editing applications. It's a virtual assistant, image indexing, and for social media also it's very important. Uh, and some other new technologies, new ideas where there is need to extract information from an image. Maybe say space, when it comes to space technologies. Okay, if our satellite captures some image, okay, if you train a model on the space images which can give accurate captioning, like result out of the image faster than the human beings, if you train it very well, if automatically it can give you what is there in that image whenever for example there is a satellite, okay, which is continuously capturing images and sending it to people down. Now human beings can't continuously keep eye on that, like what is the things, what are the things are coming, okay, some information may miss. So what if uh, we have a model to the satellite cam, or whatever the data comes from satellite cam, if we filter through our model which can caption it, for example a comet moves, like the comet movements and some other random movements will happen, okay. So in that case, if it continuously captures image and it gives captions whenever it says like there is a movement of an object, there is a movement of a comet, it will alert. Okay, it says okay, in this timeline this moment has been happened. So there are so many opportunities and so many ideas where you can apply all these stuffs. This was the one thing, okay, cross-lingual and space related things can be done using this. Now let's move on. Initially, I am importing all the libraries which are required for our work. I don't think you need a deep explanation about these libraries. Uh, I can say like, okay, I will keep it very short. Okay, import OS is there. Import OS nothing but operating system. If you want to access any files or anything from the system, you need OS library. R is used to access and change any text or text oriented, like maybe if you want to access some text from the sentence in our dataset. What is our dataset? Okay, I will show that how our dataset file looks like. One will be having all the images and another one will be having this text file. What it says is there will be an image name and the content of the image. You need to have two things for input. One is input and output for training. For example, to keep it simple, if you want to train a person, sorry, a baby, small baby, for an apple, what you will do, you will show an apple and you say like this is the apple. When you show an apple, its features are input, that image of that apple is input. When you say this is a apple, that sentence is output for his training. Like that, you need both of them for training. uh, just understand that these machine learning and deep learning models are just like babies. It exactly work like that. So we need, for training we need image and the content of the image. So there's next library numpy. Numpy is actually used to work with arrays and matrices. And then comes matplotlib, which is used to plot the graphs. Then comes tensorflow. This tensorflow is also used to work with multi-dimensional arrays. We call them as the tensors. I will be explaining below what all they are doing. Maybe uh, keras, layers, efficient net, and text vectorization. All these libraries will use them below. Initially I am downloading it from some GitHub. To download it you can do wgetq and the link of that data set. That's what I am trying to do here. Okay, I am directly downloading it from some GitHub repo. That data set GitHub repo, this people GitHub repo itself I am downloading the data set directly, and I am extracting that. I'm unzipping that. I'm extracting the files. Once I extract, I don't need those zip files to be there. I am removing that. Okay, only extracted files will be there. Now under Flickr 8K dataset all the images will be there like this, or like this. All these images will be there in Flickr images dataset. Now we call these as hyperparameters. We'll try to initialize them during starting point itself. You can see that image size we will define here itself. You can define anywhere in future also. You can give value there, but if we make it as a variable, it's very easy to access there. Okay, and vocabulary size also we are setting this much, and sequence length max 25, embedded dimension. Okay, it will be 512, and feed forward network uh, layer pre-layer will be 512, and other training parameters are like batch size and epochs. When I told you like accuracy was less, what you can do, you can increase this batch size. With increase in batch size there is possibility of increasing in accuracy. With the increase in epochs there is a possibility of increase in accuracy. And I will tell you in future, in next part, where you can do the some changes where it will lead to better accuracy. I will try to tell you all the possibilities. Okay, keep on watching. Okay, you will get the things clear. Don't try to download this Jupyter notebook and directly run. You will miss some concepts. So follow up. Okay, only it will take 15 to 20 minutes. After that you can play with this. Okay, iSlice is there. This library I used to slice out a dictionary below. I will show that. Now comes the first part. Here what I am doing is I am loading the text file. I am loading the text file and map them to corresponding images. And then what are the inputs I needed? Path to text file is my input. That what we call it as an argument or input is needed. And what it will return, this is a function. Okay, what are the steps are happening here in the first function? Okay, here pre-processing of text file is happening. We have two things, one is image, another one is text file. We need to do pre-processing of text file and the images. So our first concern is text file. What are the pre-processing is needed for text file? That we will do it here. We will see that now. Okay, caption mapping final result is there. What that will be? Dictionary mapping images names and then corresponding captions. Here only we will say as you saw here, maybe as you saw here, this is separated. There is a text, there is an image with some hash and number. This is not proper. So we need to build relation. So in which way we can build a relation in Python? Dictionary is the best way. If you build a dictionary which maps this image to this text, this will be key, this will be value, like that. This, if this is the key, this will be the value. We need to build dictionary like that. For that what we will do, I will be calling a function here. For that function what I am doing, I am feeding the text file path. Once it gets text file path, okay, file name will come here. It means it will open that file name, it will read all the things line by line. Read line nothing but it will read them line by line. I am creating three, one is dictionary, one is list, and another one is set. Three of them are empty now. we will put something into them. Now next, what we'll put other, that we'll see now. Now when I am reading each line by line from the text file, first thing I will do is I will stripe out. Okay, I'll stripe out nothing but I'll split by space. Okay, I'll split lines and then I will split by space. Okay, when I split by space, two things will I will get here. With space, this will become first part, this will become a second part. You can see that. Okay, I will try to and I commented it out. Okay, I'll run it now. It will take a bit time, so I will, in that time I will try to explain it. We'll try to split by space first, and after that you see there is a hash symbol which we don't need. So we'll try to split by hash and we'll take only 0th part of it. It means in our case what happens, it will select this, and where there is hash, this will become 0th of that, and this will become next part of the hash. So we'll take only 0th part of hash. Only image name will come. We'll take that image name. Okay, we will join image path. What is image path? Image path is here above. Image path is Flickr 8K dataset. That is a folder name. In that folder, this particular image will be there. What is that particular image is? You can see it here. This .jpg. This image will be there. Now I will append that. Then I will get complete path. Okay, complete path I will get. Yeah. Now tokens I am doing. Tokens nothing but whatever the captions are there. Okay, till here I got image name separated and caption here nothing but it will be having text, the second part of the data set, that is this now will be called as a caption. Okay, this is caption variable. Okay, each caption what I will do, I will split that captions and I will take tokens out. Tokens are nothing but words in the sentence, and I will check if there are very less or very high. Okay, if there are any very less number of words or very high number of words, I will not consider that. Okay, I will take only a selected number of sentences. In the same way, I will try to append start and end to that captions. Why? Because it will help us to, here you can see here start and end is appended to each sentence. It will help us to start and stop the captioning process. Okay, and I will append and I will make two text files. One is caption mapping and text data. Caption mapping now will be a dictionary like this. Flickr dataset JPG will be mapped to this sentence, particular sentence. Okay, and another way, okay, second image will be mapped to second sentence, like that. Okay, mapping is done. Here you can see it's printing like that. Okay, and now we will comment them out. We will see the results. For example, print line, it will read the line. I'll say it will split them by space. Okay, we'll see how will be the tokens first. What are tokens? You'll understand it. Okay, as I explained you, tokens now will be a words of each sentences. I think you can see that here. We call them as a tokens. So tokens are created. Now caption mapping I shown you. Caption mapping nothing but mapping image with its name in a dictionary. And after this, Now what are the things we have? We have two stuffs. One is a dictionary which contains a image path and a text label, and another one is only a text data. Two files we have. Now our next step is splitting the data for training and testing. What is dataset splitting it up? I will try to explain me using some drawing. Okay. For example, if there is a baby, you have 100 fruits with you. Now you need to train him. A small baby, you need to train what is a particular fruit and what its name is. Okay? You can skip this part if you know already what is the data splitting, like training and testing splitting stuff. Otherwise you can watch this. Okay, you can split to next part of this. Here in this case, what you will do, you will show him a fruit and you will tell him like, okay, this is an apple. Like this, for training you will select 30, you will keep 30 outside in another box. You will take only 70 out of 100 for training him. You will take another fruit and you will say, okay, this is a mango. Like that you will train a boy. In this case, whatever the fruits you are using, while you are showing, what are the things you will show? You will show its color, you will show its size, you will show its shape or like that. So all they become feature of training input, or we call them as a training features or training input, we call it as a training input. And you will be telling the label, this is mango, this is apple, like that. That will be training output. Okay, once he gets trained very well, you want to test him. If you want to test him, you can't use the same fruits which you use for training for testing. If you do like that, you will predict it very easily. You will not get how much well he trained. So now what you will do is, you will take that 30% which you separated, you will take one by one and you will give it to him. He will give some prediction out. Okay, you will say, okay, this is mango. Maybe you showed a apple. Okay, you showed a apple. Okay, he said mango. He predicted it wrong, and then you showed mango. He told like, okay, this is mango. Then he predicted it right. What are the what are the fruits or inputs you are showing to him for testing? We call it as a testing input. And what are the things he is predicting and giving as output? We call that as a prediction output. And you already know the label, what is mango and what is apple. That is testing output. This testing output you will compare with predicted output, and you will get accuracy. How much accuracy out of 30 fruits, how many is predicting? If he predicts 10 out of 30, okay, you will get the ratio, how much percent like is predicting right or wrong, like that. In this case, now splitting is 70% for training and 30% for testing. In our case here, the same thing happens. So here we need to uh, split the training and testing. Here I am selecting train size as 0.8. That means 80%. 80% we are trying to split the data. Now what I am doing is, I am taking caption data dot keys. Keys nothing but only text values. Sorry, images. Okay, keys are images, values are text line, because that is a dictionary of image path, image name, complete image path name, and a text. Where now caption dot keys gives us image path, caption dot values gives us a text. So here I will be getting list of all the complete image path names. I will take them and I am trying to print some top things. Flickr dataset dot jpg, here you can see Flickr dataset dot jpg, like that you can see here. Here you can see, okay, all the image complete path will be given. That's what we are doing here. We are trying to get all the complete paths. And why we are doing shuffling? What is need of shuffling? uh, Actually, in some datasets what happens, they will try to arrange them in sequential based on the size of the sentences or like that. If the first smaller sentence after bigger sentence are like that, here you can see in the structure there will be some, in some datasets it will happen. That's why if needed we can do shuffling. For example, what some dataset will do is, okay, first they will keep two-word sentences, two-word sentences. They will try to increase the three-word sentence, four-word sentence after like that. That means it will be in a format like that. We don't need dataset should be mixed up, okay, not be sequential, then only you will get better accuracy. So shuffling we'll try to do the shuffling. Now we are trying to split the data, and then we are splitting the whole image list into 80% and 20%. Our train size will be now 80%, and 80% of the whole text will be nearly 6114. Like out of 8600, 114 images are used for training. For validation it will be remaining like 1529. That's what we are trying to display here. Now what we are doing, we are trying to create a list of special characters. Okay, we are trying to return a list of special characters, and the most important thing that we are doing is, whatever the sentence, whatever the alphabet are there in our words, everything will be converted into uh, a smaller case, like lowercase, what we say lowercase sentence. For example, result will be like this: stay hungry, stay foolish. I try to write it as a stay hungry, stay foolish with capital first, but then when I feed it to that above function, it will give me this one: stay angry, stay foolish with lowercase. Why we do this is, for example, uppercase and lowercase, it will be a different thing for our model. It may get confused. It will become, for example, there is a smaller and one is capital A. A model will get confused. What is that? You can train it, no problem at all. You can train it for smaller and a capital lower and capital letters. But why there is no need to do that? How much you reduce the data set and size of the data set, it's that much better to go and do the training faster and get good accuracies. So that we'll do text pre-processing. This is one of the text pre-processing, and then we are going to vectorize. What is this vectorization? I gave this a link for you. You can go and visit that Keras site for more. What this function will do, what are the things that we are feeding? First we are feeding vocabulary size, what maximum vocabulary it should have, and then sequence length, what is the maximum sequence length or output sequence length it should have. Custom standardization is the function above function. It means whatever things comes in, everything should be converted into lowercase. So in the end what we will get is, uh, whatever the information you send it, vocabulary. In vectorization we are getting out vocabulary nothing but here mapping is done. For each word you what you see, there will be a mapping to some number, some integer. You'll see that here they only defined it. Yeah, a standard no, no, no. Here you can see, for example, if there are any words, those words will be now getting arrays. This is what done by the vectorization function. In our case, yeah, all these words vocabulary I'm getting, but vocabulary will, each vocabulary will be mapped to some values. Okay, it will be a map of a word with a number, word with a number. Say owner may be one, music will be two, ladder will be three, giving will be four, like that. But it will be an array. Okay, not a single number, it will be one dimensional or a one dimensional array. That's what I am trying to print out. Why this is needed actually? we should keep one thing in our mind when we work with deep learning and machine learning. All these are set of rules and equations which accept only numerical data, maybe arrays and matrices, maybe integers and floats, but not any strings. So whatever the data you have, you need to make it and convert it into some numerical data. You can convert it to integers, floats, arrays, matrices, do any numerical part. You should convert that. But vectorization of a TensorFlow, which can do that task, which can take all the lines text of our data, which can take out all the vocabulary, that means words in those sentences, and it will map them to a number, that is array, an array. It is done here. And what we do, we do image augmentation. Why the augmentation is needed? First of all, what is image augmentation at all? Image augmentation nothing but, I'll try to explain it. With the same example I will try to explain what I okay. Now you are training a boy, okay, a small baby, you want to train with the apple. Okay, now you will show this apple and you will say like, okay, this is apple, and you keep it aside. And you will take mango, okay, you will show that mango to him, and you will say, okay, this is mango, and you will keep it aside. Now you will learn about the fruits, no problem at all. But when you test, if you show this apple in some other orientation, whether he can predict it that much easily, he may predict it, but there will be a more possibility that he is not going to predict it properly, because you will be seeing in only one direction, only one way. So there will be a problem. What if you take this apple fruit and you rotate it in all direction, and you try to show him in all angles, okay, this like this, like this, like this, and mango also in all possible flips you will do, turns, you will turn it, you will low, up and low it, right and left, you will do all the combination of the stuff, and then you show the fruit and you will give it to him, and you will say, okay, this is mango. In that condition, there is a possibility that you will learn very better. Same thing happens in our case. If we have an image, if we feed that image to a model directly, there is a possibility that we may not get properly learned model. But what if we do augmentation? Augmentation nothing but, which we take one image, we'll flip the image and we'll make another image with same tag, and we'll try to uh, in our case we'll see in the code what we are doing. We will rotate it randomly, we'll flip it randomly, and we'll change its contrast, like lightning contrast randomly with a 30% change. Like this, if we do, we'll get a new image that is changed somewhat. So that new image also will use during training. So there is more possibility that we are going to increase the accuracy. Now, till now, whatever we are doing, finally text files, we got a text word mapped to a number. Now image is augmented. Now what we need to do, for example, with the drawing only I will try to show you that. During training, what you did, you took a mango, you said like, this is a mango. It means you boxed them, you kept them in a single box, okay, this is mango and mango is a word, you told them together. It means you batched them during training. We call this as a batching. Okay, in now what I will do is, whatever the text I got from the mapping, like each word mapped to a number, that I will take one side, and the the image input, in my case the particular image, flicker image, I will take, and I will take that number and I will batch that particular image and the particular array of a text. Like this, I'm going to batch all the images with all the text mapped numbers. So here you can see that batching is done here. In this function I will apply that augmentation, resizing. Okay, first I will read the image, next I will decode, next I will resize, and next I will convert the image, and I will feedback. Okay, and the same thing happens with the text file. Both of them I will take them here and I will batch them. Okay, I'll batch both of them. Once the batching is done, okay, I will get the original data set. That data set, okay, that data set I am going to split it into two ways. One is for train, I will do the same stuff. Another one is for test, I will do the same stuff. I will call this function make data set function below. Make data set function I am calling here. Once I call make data set, it means if I push my training data, it will give me a trained data set, batch data set. If I give my validation data, it will give me batch data for validation. Now we'll start to build a model for this. First thing is we are going to build three models. One is CNN model, another one is encoder, and another one is a decoder. What CNN will do? It is used to extract the image features. What are the image features? Features nothing but in here in this case the entire image as a pixel array. So, and what our transformer is going to do is it is going to extract the image features and then pass to a transformer, that means the encoder, that generates another representatives for the input, and then decoder will take that and it will learn to predict the caption. That means actually our main model is the decoder model, which will learn to predict the caption for our image. Our encoder will only convert our data to some other format, some other array, some reduced array, or like that. I will be explaining about these models separately in some other video. It will take a lot more time for that, and I will explain it, okay? And only if you message me if you want the explanation about these models in depth, I'll try to explain it. Otherwise I will not, because it will take a lot time, and if you don't need, then there is no need for me to explain it, because I'm going with your interest. So if you need explanation over these models, all these are model building, of course. If you want me to explain, just message in the box, okay? All these are model building stuffs. Okay, once you are done with the models, we are going to build a bigger model, that is caption model we say. Here what I will do is I will bundle them, okay? First will be my CNN model, then my encoder and decoder. I will bundle them and I will push the image data, image with image augmentation function. It will take all the data, and this final model will be caption model, which will be a model of bundle of three models. One is CNN, encoder and decoder. Then I am going to compile that model with defining what is the loss I need. So early stopping you can define, or if you don't define then also fine. Early stopping nothing but if there is not much accuracy difference between two epochs or three epochs, you try to stop that, okay? If you don't use this, then also it's fine. And then how many epochs you want to train, and number of training steps. It is just length of train data set into epochs. Above epochs we define 30, so it will work like that. And after that you will fit that caption model. Caption model is now will be a bigger model which contains three sub models. One is CNN, one is another encoder, and another one is decoder, okay? Using all of them we are building this bigger model and we are training it now using our training data as an input, train data set as an input, validation data set for the validation, and callback you can remove this callback. If you use callback, what happens in my case, it stopped to 12th epoch, because it got to know that okay, if you train like 12, 11 and 30th epoch, all three epochs, there was not much change in validation accuracy, so it stopped there. If you remove this callback function, it will run till 30th epoch. There will be a chance of increase in accuracy. I faced that. So the best way is try to remove this callback function. So you can run it for as many epochs as you want, maybe 100. There will be a chance of a rise in accuracy and a reduction in loss. You will get better accuracy. And then we are going to apply it on some of our images. That is generate caption. This function I am doing, what it will do is it will take some random data, random choice of valid images. Okay, from validation images it will take some random images, one random image, and it will first resize it, and it will convert it into array using numpy, and it will try to show that image, and after that it will pass that to my trained model called caption model. Okay, for that, and after that to encoder, this result is sent to encoder, and then that will be fed to decoder. Okay, encoded result, what are the encoded image, that will be fed to decoder, then we will get the result. Okay, that's what we are giving here, image with a predicted caption, image with a predicted caption. Here I am doing it around, I think, okay, 12. For 12 images I am doing. You can customize this, customize nothing but you can take any image from Chrome, and instead of valid images are like this, where you need to change the stuff is, yeah, here you can give your own path, image path. Okay, to take that image as an input, and it will generate the caption for that. Okay, yeah, I will be sharing this code to you, and I will be helping you to run this. If you just message us, there will be contact number below attached. You can call me at any time. If you like this video, try to like and subscribe our channel. You'll be getting so many other videos which will be very helpful for you if you are preparing for any interview, and yeah, that's it. Okay, there is any need, just call us, contact us. Thank you very much for your support. Yeah, we'll see you soon.